Well, it's been a while, but I'm back. I have a new, well, I had some questions about notch factors and why sometimes when we put cross sections in on a shaft and we're doing an analysis, we don't get notch factors we think we should have. So I just constructed this simple little shaft. I've got an input coupling, I've got an output coupling, a couple supports, so the shaft is supported, a couple cylinders. I have a cone right here, you can see that, and I got a third cylinder with a spline. So I've got a spline, I got a radius, and I've got a cone, and I've got a couple. I've got some power here. So I have an input spline. If we look in the element editor, it's my driven, it's my input. I've got 500 foot-pounds of torque on it. I have an output spline and a coupling on that, and my output, see it's driving output. I have 500 foot-pounds. In my basic data tab, 1500 RPM. Got a steel housing, which is fine. And then my strength, I'm using a calculation. It's a DIN 743. Limited life strength, 100 hours. Required service life. Okay? So, simple shaft. What I need to do is I need to calculate and understand some of these concentration factors or notch effects in the bending, torsion, that sort of thing. So I'm going to highlight my shaft here in the element tree, and I'm going to look at my material. And I'm going to grab maybe a thru hardened, a 1045 thru hardened steel, standard steel. I say okay. And so this is my material, my shaft. I have the loads as I had mentioned earlier. What I'm going to do is I'm going to go to my cross sections. I'm going to do a right click, and I'm going to set the critical cross sections. And you can see I have, looks like 5, A, B, C, D, and E. Now A, B, C, and D, I will have notch effects. So I run this calculation. Oops, let's run it static. Oh, sure, right here it says my static calculation is not reached, right here in the static. But before, remember my results, all I had was the support 1 and 2. I didn't have these fatigue safeties or the static safeties on the shaft. All right. So what's important to note is cross section E. If I click on any of these cross sections, and I look at the element editor, I can see the notch factors. They show right up right here, and it tells me the notch effect. It's a spline in this case for A. For C, there is a smooth shaft. There's no notch effect. For B, it's a shoulder. You can see the notch effect value right here. For E, it says 1. It says smooth shaft, but we know it's not. It's a cone. So there is a notch effect there. And then for D, cross section D here, it's a spline, and we have a notch factor. Okay. We are interested in E at 67. I'm going to delete this. I'll show you why. I'm going to go to my cross section, and I'm going to add a free cross section. I'm going to call this cross section E-E conical or cone. We'll just call it cone. I'm going to put it at 67 because that's where it was, and it's right at this cone right here, right at this intersection. Now you can see I have some different things here that I can choose, and one is a notch effect, and I can define the type of notch effect this is, right? Cross holes, threads, all these things. This is a conical shoulder. If I click on this, I can see the main diameter, the large diameter is 48, and this diameter down here is 38. So I go back to my cross section. I say conical shoulder, larger diameter of the shaft, 48. I'm going to click on here, smaller diameter is 38. I have a 0 diameter in the bore, and my angle of inclination, it's close to 45. We'll say it's 35 degrees. It can be whatever you want. And then this transition radius, this R, if I hit an F1 here, that doesn't tell me much. But this radius is this radius right in here. Okay? Because if I right click on here and I say I want to add a radius to the left, nothing shows up. Right? So I can't put that in there. But what I can do is in my cross section, I can define that as a 2.5 millimeter transition radius. And that is this radius right here. It could be 2.5, could be whatever. All right, here are my notch factors. Here's my surface roughness. Maybe my surface roughness should be, maybe it's milled or turned. I don't know. 8 is pretty good. So now I run this. Okay. So it's not defined in DIN. It's carried out according to FKM. This is just an information window that comes up. So what it's telling you is that it's carried out using the FKM recommendation, since the notch factor for a conical shoulder is not defined in DIN 743. So we're using this recommendation. All right. Static calculation not reached. Now, so here's my cross section EE, and these are my notch factors. All right. So I just put this information in here, and now I have a notch factor. And maybe it's 45 degrees. If I change that, I can play around with this. What do my notch factors go to? Went from 1.6 to, well, let's say about the same. So you can play with that a little bit. But that'll calculate your notch factor here. And maybe I need to have a bigger radius. What does that do for me? I drop my notch factor. Okay, so I have a large radius coming across here, so that dropped it. If I go to my results calculation, I can see that my cone is not the driving issue here. The issue is section AA. AA is a notch factor. If I click on this, it's a spline. Okay, so maybe I can't have that big of a spline. And if I click on my spline, you can see I have a 32 millimeter shaft. If I click on my cylinder right here, I have a 32 millimeter diameter shaft. I can change this spline from a 15 to a 31 or a 63 or a 9, whatever. But I'm just going to grab this 31.2 spline right here. And you can see how this changed. Right here, it changed the depth of the tooth. Now if I run this, my static safety is 1.24. Okay, and that's at my cross section A. My cross section D is 1.73. And again, I could do the same thing here. I could highlight this and say, well, it's a 38 millimeter. Maybe I should have 37 teeth and change that to a 1 millimeter module spline. And if I do that and run the calculation, I can see cross section D went from 1.73 to 2.15. Okay. So this is a quick way, if you have cones on your shaft and you need to calculate that or in a rough or quick manner, it's an easy way to define your what this notch factor is. And you can see the effect, and you can play with this pretty quick. I would recommend, however, if it's a very sensitive, if it's not over-designed a lot or a little, or if it's on the verge, I think KISSsoft is very good. It relates very well back to FE, but sometimes you might need to run an FE, calculation on something like this quickly, and it'll grab some of the things that are, the nuances that we don't see. The same thing goes with shoulders and radiuses here. So we run this with a radius. The radius happened to be 4 millimeters. Okay, that's at section B. You can see the value here is 1.58. If I were to change this to 2 millimeters and run this, I expect that to drop. Well, it didn't drop very much. Well, it did here on the fatigue. It went, see what did it go? 1.87 to make this 4. So it was 2.02 and then went to 1.87. So you can play with this and see what happens when you make these little changes. So that's how you would set a free cross section and how you define your own notch factors. Pretty easy to do. Play with it. See if it affects your FE calculations. Something on a simple shaft like this, that FE calculation takes maybe a minute, if that. But good luck with that, and hopefully you're staying safe during the COVID.